Hello and welcome. Today on the bench we have a Tektronix 1503 time domain reflectometer, and these are used to measure cable length or length to a fault in a cable, and I believe I should also be able to tell the impedance by watching the size of the return pulse as I change the impedance setting here. But anyway, this would come in handy if you've got several different spools of coax laying around and you're not quite sure whether they're 100 or 150 or 125 feet. Rather than unspooling them and measuring them, you can just connect them to this jack here, and you'll be able to adjust this and measure how long your cable is. I picked this up at a surplus store by the name of ESS, and I thought they had gone out of business, and it turns out they had just closed the retail store, but they are still an online presence. And luckily, if you purchase something and you're in the New Hampshire area, you can save on shipping by merely swinging by and picking your item up once you've paid for it. Now, this is advertised as non-functional. That is, they said they turned it on and it did not power up. So I went ahead and bought it because I did a quick look online, and it appears it has an analog power supply, and the fact that it's not powering up should be fairly easy to repair if that's all that's wrong with it is a power supply issue. I do have a service manual on order. The one I found online is for the 1503C, and I don't know what the differences are, but I figured I'd order the 1503 service manual and see what happens when it comes in. This particular unit has the XY external output module. That is, this is for an external plotter, and it will plot whatever is on the screen for you externally. This is also available with an internal printer plotter. It will give you the printout right on a roll chart. I have no use for either one of those. I would be simply using it as a local function, be able, to measure cable. The manual is going to cost me almost as much as the unit did. So it says will not power up. So that tells me they have already supplied or applied power to this. So I think I'll go ahead and do the same and just verify that. Let me dig up a cord. We have a cord. Since they've already plugged it in, I don't suppose I can do any more damage than just following along and verifying that it doesn't power up. I'm sure they're right. They're usually pretty good about this. And there we go. It's plugged in. And there's the power button. And we'll see what happens. Dun, 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 dun. Looks like nothing. Alrighty, I'm going to unplug it and we'll check the two line fuses here. That's probably the most obvious thing to check first of all. Another thing I should take a quick ooh, sorry about that, buddy. Another thing I should take a quick look at is this is supplied with batteries, or can run on batteries, not supplied with batteries. What am I talking about? My fear is, I've never seen the inside of one of these. This is my first go around. My fear is the batteries have leaked all over the power supply, and that may have been what caused it to fail. So let me get a screwdriver and see if we can get this battery pack out of here. Okay, I've got a little screwdriver, and always have the right size for the screw. Oh my goodness, that doesn't want to move. Alrighty, let's try this. Wow, that certainly is stuck in there. I hope it isn't corrosion causing that. Let me get a bigger lever and see if I can move this. Okay, we have a bigger lever. Let's see what happens. There we go. Well, there doesn't appear to be a lot of corrosion. There is a fuse in here. We'll have to take a look at that. What's it rated? 3 amps. And it looks like NiCad C cells. So even this, though this is leaked slightly, it doesn't appear bad. We should be able to rebuild that battery pack. Oh, and that's nice. I don't know if you can see in there. There's not, that's completely contained. Let me get a light. And the connections on the back aren't corroded. So it looks like it probably isn't corrosion damage. I don't know if you can see down in there. There's a little bit of debris from the batteries, but the terminals in there are clean, and that's completely sealed off from the rest of the unit. So it's not battery damage, which is good. That means no destroyed circuit boards. Let's take a look at the fuses in the front. It may be as simple as that, or it may be something more sinister. Let's see. What are these? They should be 1/2 amp for 115 volts. And let's see what this one is. Yep, that's 1/2 amp. That's a good sign. It doesn't look blown. It's a slow blow. That does not appear to be blown. And that's a 1/2 amp, so we'll turn on the continuity tester here, because these can fool you. These little wire wound slow blow fuses. And we'll put this meter over here on continuity. Meter, measure, continuity, enter. Let's see what we got. Okay, that one's alright. And that one's alright. And I don't know how far we're going to be able to go with this until the manual comes in. But it appears these aren't blown. Now, it's very common for these units to also have internal fuses. And again, the manual I have is for the C model. And it doesn't show fuses on the power supply, but let's see what's inside of this one. And if this is since this is Tektronix, these 4 screws should let the whole unit slide out the front. That's typically the way that Tektronix scopes come apart. So we'll take out or loosen the 4 screws. And I'll bet they're captive. They usually are on the Tektronix line. Tektronix used to be such a great company until they decided to go the route of not supplying service manuals, like Hewlett-Packard no longer supplies service manuals. Or excuse me, they'll supply a service manual and it'll say check this voltage, that voltage, and the voltage over there, and if they're not correct, change the power supply. It's just the way of the world today. Okay, those are loosened up. Will this come out? Come on. Well, it moved a little bit. Let's see if we can gently prise this out. It should come out this way. There it comes. A little gentle persuasion. Alrighty. Check inside of here. Oh, that's interesting. Can you see down in there? There's a pair of terminals just like the ones on the battery. And there's a line cord connector. Let's see if we can get that. Yeah, can you see the line cord connector down there in the bottom? So it appears that This is duplicated, as are the connectors that are internal. It looks like this has been weatherproofed. Ah, sure enough, there's the AC in on the back, and the DC terminals are inside of there, so everything's isolated from the battery. What a nice setup. And a can of desiccant. This unit obviously is designed to go out into the field. I've never been inside of one of these, so this is my first venture. Let's see what we've got hiding under here. Ha! The power supply board. First time. Look at that. And what do we got? Oh, sure enough, we've got 1, 2, 3 fuses, and I see right off the bat. So we'll have to take a look at those and see if any of those are blown. It certainly is nice and clean in here after being sealed up. Ah, there's another layer to the power supply underneath there. It appears that's probably for the CRT. This appears to be low voltage. That would be my assumption, but again, I've never been inside of one of these. Let's see here. This fuse is a 2 amp. Turn the meter back on. Let's see what we got here. That one's alright. Check the next one of these spares. Oh, those are spares. There's 2 extra spare fuses in here. But since that one wasn't blown, I think we're going to have to dig a little deeper here to yeah, those are just spares. I don't even know why I'm testing them, but I'll know they're good if I need them. Yep. Ta-da! In fact, I should check the one that's on the battery pack. Okay, that's alright. Let me get the battery pack over here and pull the fuse out of that. This is a 3 amp. Well, those are all 2 amp. Let's see what we got. Yeah, that bat fuse is fine as well, so it's not a case of a blown fuse anywhere. And we'll look for obvious... Oh, you know what I should check? Let's see if the power switch works. Although I suspect the power switch isn't really the power switch. It probably has a charging circuit, so I'm probably going to... Well, let's not speculate. Let's see what happens here. That says 44 ohms. This will probably be using the power cord. 44 ohms sounds like a transformer primary to me. So I wouldn't be at all surprised to find that the power switch doesn't do anything as far as the continuity out here. I'm going to have to put this back on ohms instead of continuity, I suppose. Can you see that? No, you can't. Now you can. I'll stand it up there. 44. Turn it on. Turn it off. Yeah, that's what I thought. This probably just switches the DC side of the power supply off and on. And this is probably live all the time, so that when the unit's plugged in, it's continuously charging the battery. That would be my guess. And again, I don't have the service manual for this yet. We're flying on instinct here. Alrighty, let's see what else. Is the power switch itself working? Can I even get to the bottom of it? Alright, I'm going to pull this board out. Looks like I got 3 connectors up here in the top and 4 screws. I'll take that screw out as well rather than unsolder that ground. And then I can't quite get to the terminals on the power switch here. They're up against other stuff. But I can see where they're running underneath, so if I can... Oh, there's one of them. Can I get to the other one somehow? No, it disappears down inside. Alright, I'm going to pull this board out so I have access to the wires coming off the switch, and we'll find out if the switch has failed. Okay, we got the board lifted up and we checked the switch real quick. I didn't bother filming that. And the switch is fine. And as I suspected, the board beneath it was a high voltage. It says 2000 volts on this board. That's got to be for the CRT. I don't see any swollen capacitors. I don't see any toasted resistors, transistors, circuit traces, etc. And I've looked it over pretty well under magnification. I don't see anything suspicious. I did notice this 2 amp fuse over here. It says chart power 2 amps. So that fuse must be for the chart recorder. There are some test points, -5, plus, looks like plus 10, plus 10, -5, plus 5. What else have we got on here for test points? That appears to be pretty much it. Plus battery, and this one over here isn't labeled. But when the schematics arrive, we can dig into this a little deeper. Whoops, something came unplugged underneath. I want to plug that back in. Now I'm also curious. I think I'm going to try feeding 12 volts into the battery terminals and see if it wakes up on battery power. The reason I say that is this scope meter right here will not function without a battery. It will not turn on. Or if the battery has completely quit, it won't turn on, even on AC power. It has to have a battery with some life in it for the charging circuit to see before it will power up even on AC. And it's not the first piece of gear I've seen like that. Again, I don't have the hard copy of the service manual, and reading through 300 and something pages on the computer does not tickle my fancy in the least. I cannot stand doing schematics online. Not unless it's a single page or a couple of pages, but when you get into these 300-page tomes, I want to have the hard copy so I can take it up to the Oval Office and sit and ponder. Alrighty, I'm going to drop this board back on here and reconnect the ground and the connections that I unplugged, and then we'll put some power onto the battery terminals and see if this thing will wake up. Okay, I have my power supply connected. I haven't turned it on yet. Well, I've turned it on to limit the current. The fuse in the battery pack is 3 amps. So I've limited the power supply to 1.5 amps, which should be plenty to power this thing up. The battery pack is only C cells. There's 9 of them at 1.2 volts per cell. That'd be 10 volts. Now it's probably closer to 12 when it's freshly charged. But we'll start out at 10 volts. And we have a battery indicator here anyway. I'm going to bring it right up to 10 volts and turn it on. I'm going for broke. 8, 9, 10 volts. Let's see what happens. And nothing. No battery indicator. I expect, well, unless there's a button here. No. I expected to see the battery indicator come up. It's not drawing any current whatsoever. So maybe the problem is not power supply related. Maybe it's something a little bit deeper into the circuitry. That's disappointing. I expected to see it power up on battery power. I guess my next test could be plug it in and see if the charging circuit's working. And I should probably have a battery pack made for it. I can pull the cells out of here and go down to Batteries Plus, not a sponsor, and have them make up a pack that I can put back in this assembly. I'll just take the assembly apart, take the cells to them and say, you know, spot weld me another assembly out of C-cell NiCads. But yeah, that's disappointing. I expected to see at least a battery indicator come up, and there's absolutely nothing. Unless I am totally missing something. But again, I don't have the correct schematic yet, and that book is on the way. So I guess for now, this will be the end of this video, and when we have the schematic in hand, we can dig a little bit deeper into this puppy. That was really surprising. That I fully expected to see that wake up, and at least the battery indicator move. But that actually, in a way, is a good sign. It's probably something real simple, open circuit somewhere, that's stopping this from working. I could, again, I think I said plug the thing in and see if the charge circuit's working. We can do that. Let me check that. Okay, I decided to go a different route here. I've got the 12 or 10 volts connected, and this is the terminal that says battery on the power supply board, and it's 10.1 volts, which is certainly close enough. Now we have two other test points, 10 volts, -5, +5, and I have 1.5 volts on the 10 volt rail, and when I shut the switch off, that goes away. So obviously we have a power supply issue here. It's not blowing a fuse, it's not drawing any current that's readable on the there's a little pulse on the current meter when I turn it on as it charges caps, but that's it. So there's 1.4 volts where there should be 10. -5 is basically open, it's reading millivolts, a couple hundred millivolts. +5 is reading +500 millivolts, and when I shut it off, that goes away. So something's dead in the power supply, obviously. Whether it's lost a transistor somewhere or one of these op amps will remain to be seen. I don't know what that terminal is. That could be the ground. +10 volts. That's +10 volts. That's odd. And this is +10 volts. Must be common. At any rate, until I've got a schematic in my hand, I can't make much more progress. I can go ahead and see if I get the same result on AC power, and then I know I don't have to bother with a battery pack until I've got the board straightened out here. So I'm going to go ahead and connect the AC line. Let's see here. I want to disconnect the DC power supply so that there's no catastrophes. Well, that's an interesting result. I connected the AC power supply, and now when I pull the power switch, oh, it's not doing it. There it goes. I've got a full-scale indication on the battery. Now there's no battery in there, but it's showing obviously charge. However, when I first did this, you remember there was nothing. There was no indication here. There was nothing whatsoever. And I'm hearing what sounds like a relay. Could just be this meter, I guess, going click. Let's see what we've got in here now. Let's be careful. All right. Now we have 2 volts. We're running on AC. We had 1.5 volts there. We have 2.3 volts now on the 10 volt bus. We have plus 300 millivolts on the minus 5 volt bus, and 700 millivolts. Yep, 7/10 of a volt on the +5 bus. This should be +5. It's 700 millivolts. This should be -5. It's still +300 millivolts. There's a clue, I suppose. And the 10 volt bus has gone from 1.4, 1.5 volts up to 2.3. So it's showing some signs of life. However, let's see, battery. Showing 14 volts. Yeah, so the charging circuit's working. This is connected. This terminal's connected directly to the battery terminals. So it definitely is charging. Remember, I said that 10 volt pack is probably 12 volts when it's fully charged. So that's what it's going for, is 13, 14 volts. Of course, it's not going to decay very fast. Now it's saying 16 volts. There's nothing loading it. So the charging circuit's working. Oh, the power's off. Yeah, that's live all the time. So it charges at 16 volts. Of course, it's probably current limited. I don't have the manual again, so. Alright, so the charging circuit's definitely working. That much is alive. That means the power supply, the switch, all of this stuff is good. I just got to figure out why I don't have 10 volts there and -5 here and +5 there. And when that mystery is solved, this thing will probably wake up and work just fine. So I may just go ahead and have a battery pack built in the meantime, and while I'm waiting for the manual to come in, and in the next chapter we'll see where we can go from there. I just had a thought. 2 more brain cells just kicked in. I was testing this at, I calculated 1.2 volts per cell, 9 cells, 10 volts. Then it dawned on me that this is a 10 volt test point, regulated test point. We're never going to be able to achieve 10 volts here with a 10 volt cell. There's going to be voltage drops. So since the battery is marked 12 volts, I've just booted the power supply up to 12 volts. And let's see what happens. I've got a feeling that that's my problem. Okay, let's turn the current up a little bit. Bingo. Alright, let's I think the surge is too much for that supply. I was going to measure the current while I was at it and turn the thing all the way up to 500 milliamperes. I changed power supplies here. Oh, look at that. It's awake. It's alive. And it's drawing 219 milliamperes. Very good. Okay, so like my fluke scope meter, this does not function when the battery is low. I suspect, even on AC, I suspect. Let's see, well, I was going to say I'll check the voltages, but obviously I don't need to. It's working on DC. So I'm willing to bet that right now I'm running on a power supply, and it's drawing 220 milliamperes, which means the C-cell NiCads will last a reasonably long time. It's showing full battery. In fact, let's drop the voltage here. Okay, that's showing about half depleted on the voltmeter, and that's 10.9 volts, so it'll work down to 10.9. Let's go a little lower and see where it drops out. Well, it's fading, gone. That's 10.2, and it's showing the battery in the red zone. If I turn it up to 11 volts, it's showing almost full charge, but I suspect it needs a little bump to get going. So let's see what happens. And sure enough, there it is. Okay. It's very much like my Fluke. It's very much like a couple of Heathkit shortwave receivers I've had. They had to have the batteries in them to work, even though they had an AC plug on them. I am going to, what time is it? I've got time to get down to Batteries Plus and get the pack rebuilt. So I'm going to dash down there, come back, and pick up from there if I have time. Be right back. Through the magic of YouTube, I am back with a fresh battery pack. And I have rebuilt it into the case, ready to go. But have I got a tale to tell? I walked into Batteries Plus and plunked that down on the counter. That's the insides of those are the old cells. And the guy took one look at them and said, nope, I'm not building any more of those. And I'm like, excuse me? And he said, a guy was in here 2 months ago, had me build him a couple of these, and he said he was back the next day all kinds of pissed off because they wouldn't fit. And I said, what was he putting them in? And he said, something about a scope. And I said, an oscilloscope? He said, yeah. Now, strangely enough, guess what this is basically? An oscilloscope. And I said, what was the problem? He said they would not fit inside the case. And he said, because they are evidently a little bit different in size. Well, the difference is these have a button here that projects through the hole. However, the overall size of these, if you measure from the base to the top of the button, actually, excuse me, the overall size of these, if you measure from the base to the case, never mind, excluding the button, these new cells without a button are exactly the same length here to here as these are end to end. So they will fit. The problem is when Batteries Plus builds... Oh, let me finish the story. So he said, I built 2 of these. The guy brought them back, and he said, I'm not going to build any more of them. He says, because I'm just going to lose money. And I said, so what happened? He said, well, they were around here somewhere on the bench. And I look past him, and sitting on the bench under a pile is a set of these in this configuration. And I said, that set right there? And he turns around and looks. He said, yeah, that's one of them. And I said, bring it over here a minute. And I checked the lengths, and that's how I knew I could get it in there. And I said, what do you want for it? And he said, what do you mean? I said, I'll buy that pack off of you. We had 2 of them, but I'm not going to buy them both because it's going to be a few years before they die, and I don't want to have a second set that's been sitting around. He gave it to me for 30 bucks, or gave me the set for 30 bucks, which is considerably less than it would have cost. Probably a quarter of what it would have cost to have him build it up. I bet it would have been over $100. He said, you can't bring it back? I said, don't worry, it won't be back. And I took it home and fitted in the case, and it does go in, but it's very, very tight. And the reason for that is when Batteries Plus builds these, they glue all the cells together. What happens is if there's any slight misalignment whatsoever, let me get this better in the frame here. If there's any slight misalignment whatsoever, it pushes the sides of the case out. And that is the case of what happens here. I can see a gap in here and a gap in here while these are flush. That one's got a gap. There's a gap here and a gap here while these 2 ones here are very flush. What happens is because they're glued together, they can't shift side to side and equalize inside the case. The second problem is this metal clip that's here, the black piece that's here, you see how it dips down to fit between the batteries. Well, when it does, it needs to separate them ever so slightly to align properly. It took some real finagling to get the hardware back in here. I had to clamp this thing in a vise to get the screws to fit. That's why they didn't fit. So if you go to Batteries Plus, your local Batteries Plus, if you have a scope that takes a battery pack like this, make sure you tell them just to put it, you see the yellow tape, that's the original configuration that came from the factory when they built it, and it's broken in several places because when they take this pack and put it in there and fit this clip across the top of the batteries, it has to separate them slightly so that it can fit properly in between that way, and it breaks the tape. This is where that thing is dipped down here and here, here and here. You can see the tape's broken where it's pulled the batteries apart slightly. And on the other side, it's here and here where this is and this are, because it's pulled the batteries apart slightly, and it breaks that tape when they assemble it. The tape is just so they can handle the pack without the cells floating around. And that's why I put this shipping tape over the top. It was just for convenience for carrying it. So when you have this built at Batteries Plus, explain to them in detail that just to put a single strip of electrical tape or some other kind of tape around the outside to hold them together. Do not glue the cells together, because if you glue the cells together, you're going to have problems getting these things to fit inside of the assembly that goes inside of the scope. They have to be free, unconstrained, to fit properly in the case. If you do that, they can build you a battery. If they glue them together, you're going to have all kinds of heartache trying to get this thing to fit inside the scope. This is going to be an extremely tight case fit inside the blue case. Very, very tight fit. I may even have to file a little bit off. It's humped up a little bit right here. It drops in about 2/3 of the way with no interference at all, and then as this center section gets down deep, it gets very tight, and I've really got to shove it to get it in there. I'll probably just live with it. I mean, it'll fit. I'll be able to get it out when I have to replace it. But if you don't want to have any issues, make sure you explain to them, do not glue the cells together. At any rate, 30 bucks, that's a deal. Now I suspect when I plug this thing into the unit and connect the AC line cord, everything's going to be hunky-dory. So I'm going to slide this into the case. Make sure I've got the polarity right, because I don't have to, yep, everything's good there. I'm going to slide this in. There's nothing guiding it at this point, because I just want to make sure the pins line up. And there it goes. Yeah, I don't know if it'll go in deep enough. Yeah, that should do it. Let's see what we got. Ha! It runs on the battery. Look at that. Now I'm going to connect the AC line cord and see if it charges. And if it does, we're in business. Let's see what the voltage is right now without the AC line cord. I'm excited, can you tell? All we've got to do now is wait for the okay, this is the battery here. It says 11.2 volts. I guess you can't see that. Yeah, let me put the scope up on something so it's readable. There we go, that got rid of most of the reflection. So on the battery connection here, it says 11.1819, almost 11.2. Now I'm going to connect, without turning it on, I'm going to connect the AC cord. Yeah, where's the pin? It's down, so this should plug right in this way. And let's see what we got on the battery now. 11.221. I'm suspecting this is just going to be a trickle charge. Because it's designed to be left in long periods of time. 11.21. What do we got over here on this one? 11.21. If I turn it on, okay, it's drawing power. It's 11 volts. So maybe the problem is the charger's not working. I would expect that voltage to hold. I'm going to have to wait until the manual gets here and see what it says. I would expect the power supply, however, to carry it. It's dropping fairly quickly. And the guy warned me. He said this battery pack has not been charged. So he said you're going to have to put a full charge on it. Even if it takes this thing, let's see we here, -5, that looks good. I thought that was the +5. Why is there nothing there? Unless it isn't referenced to ground. Let's see what the 10 volts. 10 volts is right on the money. Yeah, I'm going to have to see what the manual says about this running on AC. Believe it or not, I've got a pair actually of Heathkit shortwave receivers that have an AC line cord, but the unit will not run on AC even when there's batteries in it. The batteries are there to trickle charge the NiCads, and it says with fully charged batteries and plugged into the AC line, the playtime is 11 hours or something, and if it's strictly on battery, the playtime is 8 hours. In other words, the charger is of such a low current that it won't even keep the batteries charged when the radio's turned on. And I don't know if that's the same case here or not. It doesn't make sense that a Tektronix scope would do that, but there's 10.8 volts. And it's slowly dropping. So maybe that's the problem with this, is the charging circuit's not up to snuff. Maybe that's what retired this unit. We'll have to see when the manual gets here what it says about charging. I'm going to shut the unit off. And there we got 11.3. So it will charge. It will trickle charge if I leave this thing alone. Because if you remember, I think there was like 16 volts. 13 volts in one place and 16 in the other when there was no battery pack. I think it was 13.4 here. Or no, I guess it was 16 off and 13 on. I'm going to let this charge. I'm going to call this the end of part 1 for now, and we'll pick it up when the manual comes in and see what the story is on the charging circuit. I'm going to let this thing charge for 24 hours and bring the battery up all the way. At any rate, the unit's functional. Even if I have to run it on battery, that's fine. It's not something that's going to run for hours at a time. And when the manual gets here, we'll pick it up and see what it says about the charging circuit. I'm happy. It works. It functions. Can you tell? Anyway, I'm the radio mechanic. We're going to call this one done for now. And we'll catch you on the next one. Thanks for coming along for the ride. See ya.